Hi, everybody. This is going to be Atomic Structure Crash Course because we're going to try to do it in under 5 minutes. We're going to focus on this great question, what makes an atom different from each other? The answer is the subatomic particles. So these three things that make up the building blocks of an atom is what causes it to be different. And we're going to spend a lot of time talking about and learning about how these three building blocks really influence an atom in different ways. So atoms are neutral, meaning that the protons and the electrons balance out, so it doesn't have a charge. We learned in our activity that there's certain locations for different particles, like the protons and the neutrons are in the center, and the electrons are in these little orbits around it. So electrons are constantly moving, giving out energy. And we'll talk about the ways electrons give out energy later on. But that's really important to understand. Um, Also, that's super important is that protons and neutrons are the mass of the element. Electrons are so tiny in comparison that they don't add anything to the mass. So it's kind of weird for us to wrap our head around. So I'm going to give you a scenario. You go to the beach, you get some sand on your arms. It's not going to change your mass. A little bit of sand is not like going to make you jump up 10 pounds or even a pound. That's like protons and neutrons versus electrons. Electrons are like the grains of sand compared to the protons and neutrons so it's not influencing the mass even if we had 100 electrons on it. It's just too small. So when we talk about atomic mass, we are just talking about protons and neutrons added together. So once you know the proton number, we can figure out the neutron number, because you're always given the atomic mass in the periodic table. Now, the periodic tables, you're going to see some of them, the mass is decimals. That is because atoms have what we call isotopes. It's just the same element with a different mass. Also can be confusing. So here's your analogy. Me and my friend go to the creamery. They like her more, so they give her a bigger scoop of chocolate ice cream than me. I get this little one. It's still chocolate. It's still one scoop, one atom, but the mass of hers is going to be a little bit bigger than the mass of mine. That's your isotope. We're still talking about the same atom. It's just the mass is a little different, and that can affect it. The periodic table that you created yesterday, that is a super awesome organizational tool. So many patterns in it. The elements are organized by similar properties, which creates a lot of patterns, and we'll be learning and exploring what those things mean as we go along. That is why you labeled certain things certain ways. Also, on your periodic table, hopefully, you put a key. This key is handy to remember this information. Your atomic number is always at the top, and your atomic mass is always written at the bottom. And the mass is your protons and neutrons again. So that having that key is handy because this can get confusing without it. So let's just give it a shot. Beryllium, you have a 4 and a 9.0. Which one's the atomic number? Think about it for a second. And then for arsenic, As, which one would be the atomic mass? Next slide. So 4 is my atomic number for beryllium. It's at the top. And we're going to always round this appropriately. So 74.9 rounds up to 75, and that would be our atomic mass of arsenic. It's the number on the bottom. Hopefully you noticed the other day about the periodic table is that your symbols, the first letter is capitalized. That's how we can tell one element from the other. Because every time you see a capital letter, it's a new element. We talked about this, that decimal comes from the average of all the isotopes for each one. So we got some more practice. Give it a shot on your own. With this information, can you figure it out? So your answer is on the next slide. Our atomic number is always our proton number. So that's where we get the 4. The electrons equal the protons. That's why it's 4. If I take the mass minus the electrons, I get my neutron number. So 9 minus 4